So today what we're going to look at is we're going to look at memory with Chapter 9 of the David Myers Psychology 8th edition textbook. So again, remember this is just the beginning part of memory, and memory is pretty easy, it's pretty straightforward, so we're just going to go through it as quick as we can. So when we're looking at memory, remember you're going to have to look back at the brain and the neuroscience component of these items. So memory is the basis for knowing your friends, your neighbors, the English language, the national anthem, and yourself. And as long as you're Christina Aguilera, you'll be okay on the national anthem. But there are certain things that, like Christina Aguilera did, that was A-okay. You know, she remembered the beginning and she remembered the end of the national anthem. The middle part was pretty hard for her. But she's not alone. Most Americans really don't know the middle part of the national anthem. And we're going to look at why that happens in memory in this unit. So if memory was non-existent, every single thing that happened to you would be new and strange. And so memory is important because it helps us retain learning, retain knowledge over time. So the phenomenon of memory is any indication that learning has persisted over time. So it's our ability to store and retrieve information. I bet if I asked every single one of you who was the first president of the United States, you would all say, what? George Washington, right? Because you've learned that, and that memory has persisted over time. Flashbulb memory is a unique and highly emotional moment that can give rise to a strong, clear, and persistent memory that we call a flashbulb memory. So when we look at this picture is of President Bush being told of the 9/11 attacks. And everybody in America could probably remember where they were and what they were doing when they heard of 9/11, when the actual attacks happened. And that's a flashbulb memory. Flashbulb memories are not free from error. We put other stuff in. So we put in media accounts or other people's accounts into our own, and we build up a false memory. So stages of memory. We look at encoding, storage, and retrieval. Encoding is how we get information in, storage is how we retain it over time, and retrieval is getting the memory back up to the surface so we can remember it. So think of stages of memory like a computer. Think of keyboarding as encoding. We're getting the information into our laptop. And then we look at a disk, our flash drive, as storage. And so that's how our memory, it's got to label it and it's got to file the memory away. And then we have a monitor that helps us retrieve and remember what it is that we had. So there are problems with this stuff. I mean, we do have false memories that occur, but we can also have bad encoding. So we can miscode something, and that's going to cause retrieval failure. So when we look at the Atkinson-Schliefflin's three-stage model, or the three-stage model of memory, we look at sensory memory, short-term memory, and long-term memory. So when we look at sensory memory, it's kind of short. And then when we look at short-term memory, again, it's really short. You're talking about a second, 2 seconds. And then long-term memory is something that we'll be able to retrieve over time. So sensory, there's some sort of sensory input. So we're looking at this guy right here in this plaid and this hat. Okay, so we've got the visual. As we keep staring at him, we're starting to encode, we're starting to put in things. You know, he's wearing plaid, he's got some really bright, shiny teeth, and he's got a hat on. As we're encoding it, we're now putting in those nice little details, and we're labeling it so that when we see this guy, when we're going to the bathroom at the baseball stadium, we're going to remember, oh, he's kind of an angry guy, and we're going to stay away from it. So the ability to be able to retrieve it means we've been able to put it in long-term memory, and we're able to actually get it back up. So problems with the model. Some information does skip the first 2 stages. Some stuff automatically goes into long-term memory, and you're not real sure why. It's just certain things are easier for you to remember than other things. Since we cannot focus all the sensory information in the environment, we select information, that's selective attention, that's actually important to us. For some odd reason, the guy in the plaid shirt seemed to intrigue you during the Cleveland Indians game, and you were watching it. The nature of the short-term memory is more complex. Maybe there's actually more that goes into our short-term memory than this. We have this thing called working memory, and working memory proposes that when you're looking at something like auditory and visual, it's being actually controlled, and we get these little buffer things that go on. So And working memory, what we're looking at here is you hear something, and particularly like with historical dates, so like 1066, you know, William the Conqueror conquers England. So 1066, 1066, and you keep repeating it to yourself, and so you're hearing it, and some sort of buffer goes on, and it gets into our long-term memory. And visual spatial, so you see something, it'll be like one of those organizational charts, and you can picture that page, that text page or that notebook page when you were taking your notes, and when the exam comes you can see the page and you can see the information, and we get this buffer. So whatever the central executive part of our body is, it directs the focus. So decide to take a study break, get dinner. Sometimes there's little buffers in here that occur, and this is going to help us with our long-term memory. Like the buffer here might be, you know, on the way to get dinner, your mom asked you to take out the trash. And so then your body is going to have to keep the memory and keep rehearsing it to keep it in this long-term memory. So little things happen on our way to get into our memory. How we encode some information, like the route to your school, is automatically processed. Most of you still aren't using a GPS system to get to your high school. However, new and unusual information, like a cell phone number, does require attention and effort. Most of you don't remember people's phone numbers. You actually have to have your cell phone, like people's cell phone numbers, in your actual address book in your cell phone. So we encode stuff. We can do it automatically, but sometimes it requires our attention and our effort. So automatic processing, here's some things that like help us, okay? Space. While reading a textbook, you automatically encode the place of a picture on a page. So you'd be probably more spatial. Time, we unintentionally note the events that take place in a day. You will say to me, you know I did my homework because I had it at lunch. Well, you've taken note of the time. Frequency, you effortlessly keep track of things that happen to you. Like, that's the last time that person takes my seat on the bus. You know all the frequencies, the number of times something has occurred. Effort for processing. Committing novel new information to memory requires effort, just like learning some sort of new concept from a textbook or from a course. So when we look at this, processing leads to durable and accessible memories. So there's got to be some effort going on. So you're reading your textbook here, you're studying, and then automatic, that's the stuff that you don't know why, it just sticks in your head. So rehearsal. So I.mp4 is going to do these nonsense syllables, so he wants to try and figure out if people can actually memorize things. And so he takes nonsense syllables and try to memorize them. So these nonsense syllables, every single day he adds more to them and sees how he can memorize them. So rehearsal. What he's going to notice as he's rehearsing is the more rehearsal, the longer the memory actually stays. So next in line effect is when you're real nervous about the, like when you were young and you had to memorize like the preamble, or you had to memorize the Gettysburg Address. It's really hard for you to recall what you're going to say, the next line, when you have that next in line effect. So you're just so hyped up and anxious that it's hard for you to recall what's going to go on around you, and you really can't recall what's going on. Spacing effect is we retain information better when we space it out over time. So spacing effect, like you shouldn't study just the night before a test. You should actually be studying days before a test, weeks before the AP exam, preferably a month before the AP exam. But that spacing effect is going to help you retain information over time. The serial position effect, we tend to recall the first and last items on a list better than we actually do the middle. And this is what happened to Christina Aguilera at the national anthem. She recalled the beginning of the national anthem, and she recalled the end parts, but the middle got fuzzy. And she's just like all those other people in the stadium who got fuzzy on that national anthem in the middle. So spacing effect, when we actually practice, we need to practice spacing it out. So trying to memorize a Robert Frost poem, it'd be easier if you spread it out over time. As I.mp4 is actually doing his memory recall, he was able to do these primacy, the beginning ones, and the recency ones, the last ones. The middle ones he had a poor recognition of. What we encode by meaning, images, and organization. So we want to get meaning, in-depth meaning, we like visuals, and we like some sort of organization to our learning. So, well, did the word begin with a capital letter? So we're doing like a structural encoding. Did the word rhyme with the word wait? That's some sort of phonetic meaning. And would the word fit into the sentence? He met a well in the street. So semantic, some deep meaning. So results, somatic, the type of, we actually recall a little bit more. Acoustic, hearing it, recall a little bit. Visual, we don't recall actually as much on visual as we would when we get meaning into the information. So visual encoding. Mental pictures, the imagery, are a powerful aid in helping us process information. So when you look at this picture, you know, it's just a picture, but then when I give it meaning, when I try and do a somatic encoding. So I'm showing you the harmful effects of tanning and smoking. And so you can see one of the ones, you know, has tanned and smoked, and she looks older than the other one. So mnemonics. Imagery is at the heart of many of our memory aids. So we have lots of mnemonic devices like please excuse my dear Aunt Sally. And these things help us memorize long list of items and things that we might not necessarily memorize without some sort of helpful technique. So this is just memory or the method of loci. So you're trying to look at like a location and try and memorize things that way. On the link method, you're trying to give items some sort of linking mechanism, some sort of imaging to make them link together. Other organizing information for encoding, we break down complex information into broad concepts and further subdivide them into categories and subcategories. So chunking and hierarchies are one way that we help us do this. So chunking, if you look at this, can you figure out or can you memorize these numbers? And if you chunk them, they're real easy. 1776, 1492, 1812, 1941. If you're pretty good at American history, you can figure out that those are wars or things that deal with the beginning of wars. Okay. So acronyms are another way of chunking information to remember it. So you got HOMES that helps us remember the Great Lakes, and you got all these other things that help us memorize it. So we like chunking, we like these hierarchies because it improves our memory of items. So here we are in your science class. You guys have a million hierarchies. So complex information is broken down from a broad concept into subdivisions. So you take like minerals and you can break it down into even more categories. And it helps us see like the overall picture. So when we look at encoding summarized in a hierarchy, so encoding, automatic, or it can be effort. We look at meaning, imagery, organization, and organization. We can organize information in the chunks and hierarchies. So storage, retaining information. Storage is the heart of memory. So 3 stores of memory are shown below. So we got sensory, working, and long-term memory. And so what happens is we'll be able to get all this stuff out if we encode it properly. So sensory memory, a sense is coming up. Okay, so like you're looking at this, if we expose this for a very small time, there's no rehearsal, we'll see how much somebody can actually recall. And it's the same thing here. The less amount of time somebody has at actually looking at something, the smaller chances of them actually recalling most of it. So sensory memory, the longer the delay, the greater the memory loss. So you can probably memorize maybe 2, 3 of those letters, but you probably wouldn't be able to memorize the whole chart. And the longer the delay is, the more you'll actually lose on the information. So the duration of sensory memory varies for different senses. Iconic, so looking, echo, like hearing it, is actually going to be a little bit longer, and doing something with it is going to be a little bit longer. So working memory, this is also known as short-term memory, so it's just another name. We have figured out that people have a 7 or plus or minus 2 number, or 2 plus or 7 minus limit on how long they can actually memorize items of things. So this is why your social security numbers were difficult for you to memorize at first, and that's why phone numbers are a little bit easier for you to recall. So we consider 7 the magic number, plus or minus 2, and it's just because it's easy for us to retain information over time. So could you memorize any of those words? So you should be able to recall, give or take, 7 numbers, 7 up to 7, maybe 5 to about 9. That's about where most people are on recalling it. So chunking is going to increase our actual working memory. So here again is a nice long list of words. FBI, TWA, CIA, IBMs. It's because we chunked it, we could actually memorize it a little bit easier. So when we look at duration, when we look at working memory, it's about 20 seconds. So if you don't know it before and you actually have a test and your teacher's giving you like 5 minutes to actually study something, it actually needs to be a little bit more than that. So working memory duration, the times and second between presentations of the consonant and the recall request, no rehearsal allowed, you really see a rapid decline